This is the fourth day of the review, 28A through 37B. Use the graph below to find the function. So if we remember, this looks like an absolute value. So the absolute values were, our general form was y equals a times the absolute value of x minus h plus k, where your vertex, which is here, okay, is hk. And because this says negative h, it's the opposite of whatever it says inside, and we take k as is. A is our slope. So this equation would be y equals, it looks like we're going up 1 over 1, so y equals 1 times the absolute value of x minus, and it's a positive 2, so it's x minus 2 plus 0 for k. Now you probably won't see the 1 out in front or the 0 out there, so that would be our answer. B, same idea. Y equals, looks like we're going up, still going up 1 over 1, so 1 times the absolute value of x minus, and we don't have an x out here because this is the point 0, 1, 2, 3, 4, 0, 4, so x minus 0 plus 4. We take our k value as is. Now that we wouldn't have the 1 out in front again, and we don't need the minus 0 in there, so it would really be the absolute value of x plus 4. 29. Joe has $45 to spend on ground beef and chicken for a barbecue. Ground beef costs $1.99 per pound and chicken costs $2.89 per pound. Let G represents the number of ground beef and C represent the number of pounds of chicken that Joe can buy. Which inequality describes the situation? So it would be 1.99 G for ground beef plus 2.89 C for chicken needs to be less than or equal to 45. Oh, but they don't have the equal to symbol, so just less than. If he has 45 bucks, then he can spend 45 bucks. We should have the equal to symbol. Bella needs at least $25.50 to purchase a concert ticket. She has saved quarters and dimes in a jar. Let Q represent the number of quarters and D represent the number of dimes in the jar. Which inequality describes this situation? So yeah, 0.25 Q plus 0.1 D needs to be greater than or equal to 25.50. Next problem, 30. Which graph represents the piecewise function? So this first one is 3x minus 1 for x values that are greater than or equal to 1. So 3x minus 1, we'll just graph this. Y-intercept of negative 1, going up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and now we want x values that are greater than or equal to 1, so at 1 is where we'll put our closed circle, because we have the equal symbol. Sorry, my computer was freezing up. It was making me freeze up. And our other graph here, y-intercept is negative 2, and we're going down 1, right 1. But we want x values that are less than 1. So that means we want to keep going to the left. So it looks like that, and this should be an open circle there. So whichever graph looks like that. 30B, same idea. Our first one, we want to say f of x equals x for x values that are greater than or equal to 2. So that would be the diagonal line, right? And we want to, y-intercept is 0, so we're going up 1 over 1. Right, something like this. But just x values that are greater than or equal to 2, so we want to erase my first couple here. And now, because I've got the equal sign, I want to use a closed circle. So that's a closed circle, and we'll go out from there. Our next one there we go, there's a red color, is a horizontal line, and that's for x values between 2 and -3. So we're at 3, 1, 2, 3, between 2 and -3. So right here, right here, right here, all the way to -3. And now at -3 we're greater than, so that's an open circle here. And at 2 we're less than, so that's an open circle there. So like that. And then our last one, a -x minus 1 for x values that are less than -3. Well, what's our y-intercept is -1. We're going to end up not wanting that. And then -1 is our slope, so that means we should be going down 1, right 1. But I want x values that are less than or equal to -3, so I need to be going to the left, which would be up 1, left 1. And I want to start at -3, so I need to erase my first couple ones till I get to -3. Now at -3, I want to use a closed circle. At -3, that's a closed circle there. Our next problem . (31 through 33), use the graph below. A letter weighing less than 1 ounce costs 50 cents. So less than 1 ounce costs 50 cents. That looks to be true. A letter weighing exactly 4 ounces costs $2.50. So exactly 4 would be on this one because it's a closed circle. So that would be false. It costs $2. If 1 ounce is added to the weight of the letter, the cost increases by 50 cents. On everything except for, well, I guess a letter couldn't weigh 0 ounces. So yes, that looks to be true. 31 through 33, make this graph. So let's do f of x is 4. So that would be a horizontal line at 4 from 0 to 2. So from 0 to 2, we're at 4. We've got a closed circle here and an open circle there because we have the equal sign and no equal sign. We'll be at 5 from 2 to 4. So 5 from 2 to 4. Another closed circle at 2, open circle at 4. And 6 from 4 to 6. So 6 from 4 to 6 with a closed circle at 4 and an open circle at 6. 34. What is the x-coordinate of the point of intersection? So we've already solved for y, so we'll substitute in y here. So we'll say 5x plus y equals 5, and we're substituting in a -3x minus 3. So 5x minus 3x makes 2x. minus 3 equals 5. We'll add 3. 2x equals 8. Divide by 2. X equals 4. And then we'll substitute that back in for x over here. Y equals negative 3 times x minus 3. And we're subbing in our value of x, which was 4. So y equals negative 12 minus 3. Y equals negative 15. So the x-coordinate, that's all they wanted, so that was 4. 34b, the x-coordinate again, so here we've solved for y again. So we'll substitute it in over here. 4x plus 4 times y equals 8. And we're substituting in our value of y, which was x minus 2. We'll distribute. We'll get 4x plus 4x minus 8 equals 8. We'll add 8 to both sides and combine our like terms. And we get 8x equals 16 divided by 8. And so x equals 2. And that's what we wanted, was the x-coordinate. 35a, what's the x-coordinate here? Well, if we look here, we've got opposites, so we can add our equations together. So we get 8y equals negative 24 divided by 8. And so y equals negative 3. Now to find the x-coordinate, we just plug it in. So let's plug it into the second equation. So x plus 6 times y equals negative 16, and y was negative 3. So x minus 18 equals negative 16. If we add 18 to both sides, we get x equals 2. 35b. Same idea here. None of the equations are solved for, and one of them is positive and negative. So let's eliminate the y's here. So my numbers are 4 and 5. They both go into 20. So let's make a negative 20 and a positive 20 by multiplying by 5 here, and we get 15x minus 20y equals negative 75. And on the bottom half, we want to multiply 5y by something to get positive 20y, so that would be 4. So that would make 20x plus 20y equals, and 4 times 45, well, 4 times 50 would be 200, and 4 times 5 is 20, so 200 minus 20 would be 180. Bunch of different ways we could have done that. We add them together and our y's cancel, so we get 35x equals 180 minus 75 is 105. Divide by 35, and so we get x equals 3. If x is 3, we can substitute it in. Let's use this bottom equation. 5x plus 5 times y equals 45, and we're going to substitute in 5x plus 5 times y equals 45, and we're substituting in for our x value. Luckily, that wouldn't have changed our problem. So 25 plus 5y equals 45. Subtract 25. 5y equals 20. Divide by 5, and y equals 4. And did I mess up somewhere? Yeah, I messed up, because what was I supposed to substitute in there? A 3, not a 5. I don't know why I substituted in a 5. So a 3 here. So 5 times 3 makes 15. Subtract 15. And we get 5y equals 30. Now we divide by 5. And we get y equals 6. So be careful, don't be like me and substitute in the wrong numbers. Which system is graphed below? Well, this first equation Looks like it has a y-intercept of 3 and it's going up 2 over 1, so y equals 2x plus 3, and we're shading the bottom half of that, so that's going to be y is less than or equal to 2x plus 3, and this equation looks like we have a y-intercept of -2, and we're going down 1 over 1, so negative x, and we're shading on top, so we're going to be greater than. Same idea here. This one would be y is, what are we at, 3, and we're shading below, so y is less than 3, dashed line. Our next one is a solid line. Y-intercept is at 1, so plus 1. So we're going to have the equal sign because it's solid, and it looks like we're going down 2 over 1, so negative 2x. And we're shading the bottom, so we're less than or equal to. 37A. The graph shows how demand for cell phone increases as supply decreases. If the quantity demanded equals the quantity supplied, what is the approximate price of the cell phone? So this would be $250, looks like it. 37, Reach Fitness is offering yearly memberships for a flat fee of $900. However, an individual can choose to work out at the gym without a yearly membership at the cost of $15 per visit plus an initial $45 registration fee. When are the two costs equal? Looks like right there at 50. But that's not right. That graph is not right. Because if it was a flat fee of 900, it's going to be, when is that equal to 900? So it's 15x plus 45. When does that equal 900? So if we subtract 45, we get 15x equals 855. So 855 divided by 15. Well, 15 goes into 85. Well, it goes into 90 would be what, like 6? So that would be 5. And what's that make? 75. So this is 10. 15 goes into 105. What is that? 7. So 57. So that should be 57. $38A, a carpenter produces chairs and tables under the following constraints. The constraints are illustrated in the graph. Here, the objective function. How many tables and chairs should the carpenter make to maximize profit? So here we're crossing right here. This point looks to be 6, 6. This point here looks to be 0, 10. And this point here looks to be 12, 0. And the C is the X. And the T is the Y. So we want to plug each one of those into P equals 40 C plus 30 T. So the first one, 0, 10, right, would be P equals 40 times 0 plus 30 times 10. So the first one, our profit would be 300. The second one would be P equals 40 times 6 plus 30 times 6. So that would be 240 and 180. So P would equal, what's that? 300, 420. That's 6, and then the last one at 12,0 would be P equals 40 times 12 plus 30 times 0, and that would be 480. So which one's the maximum would be out here at 12,0. Here's the max, and the minimum would be up here at 0,10. 38B, the area of a parking lot is 600 square meters. A car requires 6 square meters and a bus requires 30 square meters of space. The lot can handle a maximum of 60 vehicles. Let B represent the number of buses and C represent the number of cars. The diagram below represents the feasible region. So to park in the lot, a bus costs $8 and a car costs $3. So we want to maximize our profit of 8 times B plus 3 times cars. So we've got, right here, we've got a point at, what are we going up by 5? 1, 2, 3, 4, 5, yeah, so that's 60. 0, 60. And this is buses is the X, and cars is the Y, so this is B and C. We've got a point here at 1050, B and C, and we've got a point out here at 20, 0. So we'll plug each one of those in. To our equation. Our first point we'll go with 0.60. So P equals 8 times 0 plus 3 times 60. So our profit is 180. Our next one will go with 1050. P equals 8 times 10 plus 3 times 50. So that's 80. Plus 150, so our profit is 230, and our last one, P equals 8 times 20 plus 0 times 50, and 8 times 20 is 160. So we had a maximum was our purple, here was our max, and we had a minimum was down here was our min. (39A), given the points, plot the inverse of x. So this point is, instead of being -1, 9, is now going to be 9, -1. Instead of being 0, 3, it's now 3, 0. And instead of 1, 0, it's 0, 1. Instead of 3, -1, it's -1, 3. And instead of 5, -4, it's -4, 5. So those are those points. 39B. Given the graph of f, choose the correct table of values for the inverse of f. Well, what are some points here? We've got a point here at 1, -1. We've got a point down here at 2, -4. We've got a point here at 0, 2. And we've got a point here at -1, 5. So we're going to have inverse points of 5, -1, 2, 0, -1, 1, and -4, 2. 40. Graph this. So graph 2x minus 1 for x value is less than 2. So y-intercept is -1. Slope is 2. I want x values that are less than 2. So I don't want to go any farther to the right. I want to put an open circle here. And our next one, y-intercept is 4, slope is 1, up 1 over 1. I just want x values that are greater than or equal to 2, so I want to erase my first 2. Put a closed circle here at 2 because of the equal symbol. 40b, same idea. This first graph is going to be, let's do it in green, for x values that are less than 0, so y-intercept is -2. Slope is up 2, right 1, but I want less than 0, so I'm going to go down 2, left 1. And we don't have the equal sign, so we're open circle here. Our next one, a little bit tricky here. We've got, this is an absolute value equation, so y equals 3 times the absolute value of x minus 1 minus 1, so our vertex is 1, -1. Vertex 1, -1. Right there. And our slope was 3, so we're going up 3, right 1, up 3, right 1. But we want to be between 0 and 3, so I just want to go to 3, 1, 2, 3. Open circle here at 3. And up 3, left 1, right here, but a closed circle here at 0. So it looks something like that. And then our last portion, for x values that are greater than or equal to 3, y-intercept was up here at 6, slope is down 2 over 1. Now I don't want any of these because I just want the ones that are greater than, so I'm just going to keep on counting and moving. Down 2, right 1, down 2, right 1. Losing track of where I am. Here, here, here. Closed circle here. Down 2, right 1, down 2, right 1. That's a closed circle. And I want to erase my y-intercept point. That's not part of my graph. Alright, that's it.